welcome to this presentation and Building the Future. My name is Bruno Sanchez Andrade Nuño. I'm Principal Scientist at AI for Earth at Microsoft. And I'm delighted to be here to present you the work we're doing to launch this planetary computer. This is probably the first time we talk in this detail what we're doing with the planetary computer. So it's extremely exciting. And the takeaway that I want from this is that anyone who's working on sustainability issues and the use of technology and big data and satellite images and are already just interested in these kind of tools, please reach out and let's work together to to put this planetary computer to use. Because if something we've learned from 2020 is that global issues, we need to tackle these global issues fast. And of course, um, an important one is climate change, but so is biodiversity collapse and other global issues that really need action. So I hope in my presentation, I'll be able to convince you that Microsoft is committed to harnessing the power of technology to help everyone, everywhere, to build a more sustainable future. I should also add that I joined Microsoft roughly um, half a year ago. And a big part of the reason is because I've seen this and I believed it and I wanted to be part of it. Before that, I worked at the World Bank and I worked in small startups and I did some consulting on these issues. And I was very impressed by the work that Microsoft was doing. And because we are a big technology company, I think should say that, of course, sustainability is the right moral thing to do. It's not only the right moral thing to do. We have to find a way to be sustainable, to find ways to build our economies, build our lives and livelihoods without extracting value from Earth. We have to. It's also good for business. And this has to be clear. There's no false choice on either protect the planet or do products and services. And this is just some quick numbers of what the energy optimization opportunity and in terms of technology can be used to save energy, but also to create these solutions is $60 billion. We know we need to optimize in terms of agriculture and to feed the world is going to be a tricky subject. There's a lot of economic benefits, and I'm not mentioning here. Well, you see the quotes below, but it's not extractive value like it used to be before. This is around sharing economy, circular economy, and this is truly a massive opportunity. And the carbon market, which is another mechanisms we have found to help drive action, is also a big opportunity. So not only is the right thing to do, it's also a good thing to do for business. Um, in terms of the company, Microsoft has done a ton for a long time. Since starting in 2009, making the first carbon emission reduction goals, but also putting in since 2012 an internal carbon tax, which is something that basically uh, calculates how much carbon each division is doing and then put in a carbon tax. I don't want to go into a lot of detail on what we're doing because I want to really focus on the planetary computer, but I want to give a context of what the company has done, which is it's a lot and has caught the attention of a lot of other companies and even governments to find ways to we would love to find ways not only for us to continue in this path of sustainability, but also help all stakeholders, everyone to do this. Because at the end of the day, as I said in the beginning, we are all together in this and we need to find ways to be sustainable. It just makes sense to do it. There are tons of lessons learned that the company has learned doing this. Like, for example, migrating to the cloud reduces carbon emissions compared to having your computers and your staff working on premises. Doing this internal carbon tax really helped fund innovation to drive the right behavior. We also saved energy consumption, which is very important because then you don't need to generate it, and then that's a part of making your use as low as possible. We've also found ways to use less water, which is a scarce resource, especially in some places. And as we have all learned in 2020, remote work is another way to reduce a lot of commuting and travel emissions. So going going closer and closer to the planetary computer because time is really ticking by. There is four commitments, and this other slide that I like better because it summarizes it. There's four commitments on sustainability that are key for the world, and this is how we have translated them so far. We want to be carbon negative by 2030, even removing all the carbon we have emitted since the creation of the company by 2050. And this is a scope 1, 2, and 3, by the way. This is the direct emissions, but also the indirect emissions working with our suppliers. Being water positive, which means helping replenish more water than we use. This is especially important in places where water is very scarce. Waste-free by 2030, and we're getting closer to the planetary computer. On the ecosystems, we have to round up all these environmental sustainability efforts to take care of the ecosystems, ecosystem health, preventing biodiversity collapse, and understanding, monitoring, and managing, or helping monitor and manage all of these ecosystems. And there's also commitments on land positive, which means protecting more land that we use. There is this book I really wanted to recommend, which is The Nature of Nature. It basically brings forward this idea that we need to rewild our societies as much as possible, which basically means bringing them closer to what they were in nature. If we take care of nature, nature takes care of us. Um, so what we have done now, getting closer to this, is we have learned a lot in how we can help this happen, and that's why we have a program with this AI for Earth team that I'm working on. That is also something that I wanted to talk about briefly, which is basically we give cash and credits to anyone who is working on sustainability issues. So if you are interested, just reach out to apply for these grants. We also build technologies for all of the people who are working these issues, and we also host data so that all the stakeholders, everyone who's working on these issues, has the right data in the right format to work on that. We have more than 650 projects around the world working on these issues from like more than 90 countries, and I do see, of course, that Portugal is one of these. Even though this is a global conference, it's good to look at the map and see that Portugal is indeed. Of course, this is something we could not have done alone, and we actually reach out to a lot of these partners and grantees to work with them. This is, I would say, 40% academia and scientists, 40% NGOs, but also there's a small component of commercial partners, which makes absolute sense. This is not only about creating the knowledge, like research and scientists do, is not only to also applying this in an NGO or a non-for-profit context, but also this is about helping other companies do their work better. Like, for example, iNaturalist is an app you can download and make a picture and see what the animal is, and so on with other examples. I could go on, but we have less and less time, but I'm happy to give more details if you are interested, or you want or the institution you work with or you know of, then please reach out to find ways to collaborate. This is just a few examples of some of the technologies we've built so far. This would be like the zero point 0.1 version of the planetary computer, if you like. And all of this is open source, or as much of this is open source as the grantee things make sense. So when we work with commercial services, then it makes more sense to make this as part of the services. But in most cases, all of this is open source. Like, for example, if you have images that you in a camera traps, which is something that scientists use a lot, is to put a camera on the forest or somewhere and then have make it images every minute or every time there's movement, and they need to figure out of the million images which ones have animals or plants or vehicles, and then figure out what animal that is to classify and then do surveys. This is extremely boring, and fortunately there are better and better ways to detect these animals. So we do that with a combination of deep learning AI algorithms, and we also do not only the detection if it's an animal, but also what kind of animal it is, in a similar way as the example I mentioned before of iNaturalist. We've also it also makes sense to do it with people. For example, when you're trying to do anti-poaching or vehicles, when you try to protect a natural park or national park, and then you want to trigger a notification when a vehicle comes into a place that they shouldn't be. There's the same thing with sound, which if Tagging images is boring, but at least you have animals. Tagging audio is probably even more boring, but it's also very important. You put a microphone in the forest, and then you want to know what animals are around there making noises. So that's something we've also built. The links are in the AI for it. You can find all of this, or even detecting seals or other animals for satellite images. These are all real examples of projects we've done. These are some examples of them, of all the code and all the services. If you are coding, you want to know more about it, land classification. But let's go into the planetary computer in the 7 minutes left, which should be enough to talk about it. So, built on all the environmental sustainability effort and commitments we've done and all the lessons learned, not only as a company, but also as players in this ecosystem to figure out ways to drive action. And this AI for Earth community with all the grantees and all the programs and all the work all these amazing amazing partners are doing, we realize there is a need to build a planetary computer which helps, I would say help, but it's a bigger aim, revolutionize the the monitoring and diagnosis of ecosystems. And that means that not only needs to be able to be applied locally, but also in have always the global context in mind. Local solutions don't they need to connect to the global issues. A watershed, like for example, studying something in a valley makes a lot of sense in some sense, but you have to have, for example, in mind the political dimensions. And again, if something we've learned in 2020 is that a lot of these issues are global. You cannot make plannings to protect, for example, or to understand what's happening with the pandemic if you only figure out if you only work in the context of your valley, your country, your region. You also have to understand what's happening in the global context. So this planetary computer has several components, which is the ring around, which is data, the API, which is basically how computers talk about the data and ask data and then figure out what to give you when you ask for the data. Then a computing environment, which is a way that humans then work with those APIs. So basically just like a stack. In the bottom is the data, and you can partner with the planetary computer, and then you can just use the data. You can also, if you know coding, you can use the APIs directly to talk to the planetary computer, or you can use a computing environment, a place you can code, and you can do all of these applications, which is what sits at the top. And now, in terms of applications, we have thought really hard and talked with the partners, and we figured out that a good way to classify all of these applications probably is these four buckets. The bucket of classification, like land classification, and I will have some details of the rest of the presentation. Is basically one slide per data, one slide for APIs, one slide for compute environment, one for apps and services, and one for the kinds of things we can do. And hopefully this also helps everyone listening the, translates these ideas that I've been sharing with some concrete applications. Classification, as I was saying, is basically what's where, forecasting what's going to happen with that, planning how can we help make sure that this doesn't this improves or gets better, or understand what's going on here, what should be here, and diagnosis what's the outcome of doing, having done something or doing something, like scenario planning and things like that. Okay, now in terms of data, you can think of what data do we need to protect, to save or help save the world? And of course, satellite images is one of them. So we have a longer and longer list of data we put in for everyone to work with that data and putting it to action. At the end of the day, we do know that these solutions are not held up by lack of data or even lack of knowledge. It's probably lack of action or translating the potential all of this data into how to integrate that in the way we live, in the way we work, in the way we move, in the way we understand government and society and livelihoods. So we need data for that, and not only we need data, we need ways to ask about the data so much that we need ways to figure out, okay, yes, what data do you have of this region with these clouds and these summer months or winter months and at this time. So it's very important. Give me a notification when new data comes here, and I want to see this in this resolution, and I want to combine land data and air data and water data because my region needs that. For example, in Portugal, that would be important. So you need to find a way to figure out how to use that data, and those are the APIs. On top of that, you need a way to build those applications, to work with it, and we have identified as much as we can, we love open source, or as much as we can, we do leverage not only use these open source tools, we also invest to make them better so then everyone benefits. So we have also this place where you can log in and start working on these issues. And the idea being that they are here being that again it's not about the data or the APIs or even the computing environment, is that find ways to then integrate these into, if you're a policymaker, how to make these policies. If you're a business, how do you integrate this into your work? Like for example, if you are I don't know, a hotel owner in the coast and you want to understand what's happening, what has happened in the coast for several years and what you can do to protect it, you need data to understand what's going on. You need to share these results with experts and you need to figure out together how we can help protect these issues and to understand what has happened in other places in the world. So having the global context is extremely important. Running quickly, because I have like 1 minute left, 2 minutes left, some of these applications now to try to help you translate all of this theoretical potential is the applications we are building already, like land use, like what is building, what is grass, what is paved road, what is unpaved road. This is extremely important in the global context. Figure out ways to map the footprint of land use compared, for example, to the degree of wild that we see around the world. Also, the camera traps, what we have mentioned in the beginning, is also very important to figure out the range of the species and how it's shifting in time. In terms of forecasting, can we map the risk of flooding and what would happen if there's storms and then there's water flying up the river or going into properties or parks or factories? So it's very important to assess this risk and then try to do interventions to protect these regions, maybe to plant more, to use some vegetation to protect in terms of a storm. These are the nature-based solutions, but for those, you need a lot of data. Going quickly, because time is really flying, there's other applications on planning, like if you have a set valley and you need to protect it, how do you do that? That's planning. On diagnosis, to figure out when you did, for example, protect a forest, and then you want to know if that forest has been protected years later, you want to establish a monitoring system, then we are also building applications to assess that that is indeed happening. So in essence, that is the Planetary Computer. We are building this tool with a global context and a global scale to help figure out everyone what we can do to save, to protect my timer is done. So basically, I hope I was able to inspire and share the work we're doing at Microsoft, and I'm very much looking forward. If you have questions, please reach out, and I'm happy to answer them.